Since its launch in December 2021, the James Webb Space Telescope has revealed numerous groundbreaking insights about our universe. It has provided new images of galaxies, complementing those from the Hubble Space Telescope, and has expanded our understanding of cosmic explosion remnants by exploring the early universe. One of its most recent observations has captured a stunning new deep-field image of the universe, offering a glimpse into some of the farthest reaches of space. In this image, many objects are visible amidst the dark void of the universe, each representing galaxies filled with stars and planets. Many of these galaxies appear as spiral formations, similar to our Milky Way. The most distant galaxies appear red due to their light being stretched into longer wavelengths as the universe continues to expand. This view, however, looks back billions of years in time, uncovering ancient galaxies and black holes at their centers, dating back only a few 100 million years after the Big Bang. Let us take a deeper dive into this new Webb telescope photograph that truly boggles the mind. At the beginning of everything, the universe went through a period of rapid expansion, where space grew exponentially, stripping reality of structure and creating a nearly featureless void. If you could have been sitting on a particle, which didn't exist at the time, and looked out, you would have seen only freezing, choking darkness as space expanded relentlessly, and all other objects vanished from sight faster than the speed of light. Amazingly, as space expanded, the observable universe shrank into a tiny, definite point, isolating each area into its own circle of emptiness. This period of extreme expansion, known as inflation, remains a mystery. Whether it lasted for a moment or an endless amount of time, we may never know. Any evidence of earlier epochs was erased by this immense cosmic expansion. Eventually, inflation ceased, and the universe began to take form. The force behind inflation dwindled, giving birth to countless particles that filled the expanding void with a fiery subatomic energy. The primordial plasma from which all large objects would later form began to coalesce. Within a trillionth of a second, the fundamental forces of nature emerged, marking the first significant burst of light in cosmic history. Though inflation ended, space continued to expand, but at a slower pace. As the universe cooled, the primordial fire dimmed, and basic particles combined to form the first atoms. In just a few minutes, the nuclei of hydrogen, helium, and lithium, the building blocks of all matter, were created. For approximately 380,000 years, the baby universe glowed with radiant fire, gradually cooling as space expanded even further. Then, a crucial moment arrived when the temperature dropped enough for electrons to bind with atomic nuclei, forming the first complete atoms. This marked the end of the primordial fire, plunging the universe into darkness, ushering in what would become known as the Dark Age. For millions of years, the universe remained shrouded in a warm hydrogen fog. However, within this darkness, the first structures began to take shape. Slowly at first, then rapidly, hydrogen and helium gases, driven by gravity, condensed into denser clouds, which heated up as they became more compact. Eventually, the pressure in the core of one such cloud reached critical levels, igniting the first nuclear fusion fire, creating the first stars. This first burst of starlight illuminated the universe once again, signaling the end of the Dark Age and the beginning of a cosmic sunrise. Soon, stars began to form in clusters, creating the first galaxies. These stars contained elements like carbon, oxygen, nitrogen, and iron, which were scattered throughout space as these early stars died, enriching space with more complex elements. This initiated a cycle of birth, death, and rebirth, where the cycle of stellar evolution continued to shape the universe. Around 9 billion years after the cosmic dawn, in a spiral arm of one of the billions of galaxies now scattered through space, a new star was born. This star was surrounded by a fleet of planets, and on one rocky planet, Earth, the conditions for life emerged. Matter on this planet somehow gave rise to life, evolving and adapting over billions of years. Through this ongoing dance of evolution, species flourished and faded away, and eventually humanity arose. Standing on the surface of our planet, we look up at the stars, pondering the origins of the universe and its boundless nature. The story of the universe, its origins and history, has been pieced together over centuries through the collective effort of countless individuals. Modern science has enabled us to discuss events that are both ancient and distant, inspiring us to think bigger. This achievement stands as one of the greatest of our species, considering it was achieved from a vantage point on a humble rock traveling through space. While we have unraveled some of the universe's beginnings, scientific endeavors in particle physics and astronomy reveal that we still comprehend only a small fraction of the cosmos. Observing the sky has shown us that matter is organized on a grand scale into galaxies and galaxy clusters. These galaxies, which contain stars, planets, and gases, are made up of protons, neutrons, and electrons bound together as atoms. Physicists have developed a significant understanding of the fundamental particles and forces that govern ordinary matter around us. Centuries of discovery have taught us why apples fall from trees, how Earth orbits the Sun, and that Earth is not the center of the universe. This image is simple and elegant, but the quest to answer profound questions about the universe has reached a pivotal moment. Astrophysical and cosmological observations have revealed that our understanding of the universe remains incomplete. One of the most astonishing discoveries of the 20th century was that ordinary matter makes up less than 5% of the universe's total mass. The rest consists of dark matter, a mysterious, invisible substance, and dark energy, a force that counteracts gravity. Dark matter, a fascinating substance that does not emit, absorb, or reflect light, remains invisible. Its presence is inferred from its gravitational effects on galaxies. For example, stars at the edges of rotating galaxies move at nearly the same speed as those near the galactic center, where visible matter is concentrated. This anomaly suggests the existence of dark matter, a halo surrounding galaxies. Dark matter may also explain optical illusions seen in deep space, such as strange rings and bends of light. These distortions occur when light from distant galaxies is bent and magnified by massive, invisible clouds of dark matter, in a phenomenon known as gravitational lensing. The revolutionary conclusion that the universe is filled with almost invisible matter reflects a profound shift in our understanding. Like previous paradigm shifts, such as the realization that Earth is not the center of the solar system, this discovery of dark matter traces its origins back to the Big Bang. Its distribution influenced the evolution of the universe, contributing to its current structure and the birth of galaxies, stars, and planets. The arrangement of stars and worlds in regions with higher concentrations of dark matter today mirrors the distribution of dark matter in the early universe. This enigmatic substance acted as an invisible force that guided the formation and development of galaxies. Investigating this mysterious universe requires a deeper understanding of the fundamental physics behind dark matter. Recent advancements, particularly those from the James Webb Space Telescope, hint at significant discoveries in this realm. Recent images from the telescope have uncovered possible dark stars, objects potentially influenced by dark matter, the invisible substance that governs the cosmos. The concept of dark stars was first proposed in 2007 by astronomer Catherine Fries from the University of Texas at Austin. According to Fries, dark stars would differ fundamentally from regular stars like our Sun. While ordinary stars generate energy through nuclear fusion of hydrogen atoms, dark stars might be fueled by the annihilation of dark matter particles. Although dark matter's precise nature remains a mystery, it interacts gravitationally with visible matter, like galaxies, and might even self-interact, producing enough heat and light to form and sustain these celestial bodies. Dark stars likely couldn't have formed in the present day due to the scarcity of dark matter. However, they might have emerged in the early universe, shortly after the Big Bang, when clouds of hydrogen, helium, and dark matter were abundant. As dark matter particles annihilated one another within these clouds, the resulting heat prevented complete collapse, allowing these bodies to grow extraordinarily large, up to 10 times the size of Earth's orbit around the Sun and potentially billions of times more massive and luminous than our Sun, or even an entire galaxy. The James Webb Space Telescope, designed to observe ancient and distant cosmic objects, may have already detected signs of these theoretical dark stars. Fries and her colleagues analyzed data from Webb's observations of high redshift galaxies dating back nearly 14 billion years. They identified 3 candidate objects, JADES RGS 2-1, JADES RGS 2-2, and JADES RGS 2-13, that exhibited characteristics consistent with what dark stars could display. high redshifts and point source emissions indicative of stars, rather than diffuse galaxies. Confirming the existence of dark stars would provide definitive proof of dark matter's presence and behavior. It could also offer insights into the formation of supermassive black holes, which remain mysterious despite their common presence at the centers of galaxies. These enormous black holes, millions or even billions of times more massive than our Sun, could potentially form from the remnants of dark stars after dark matter within them is annihilated. In general, our journey into the vast unknown continues, with the James Webb Space Telescope leading the way. Each new discovery brings us closer to unraveling the mysteries of the early universe and understanding the forces that shaped it. The high redshift galaxies observed by Webb act as time machines, allowing us to peer back into the past and inch closer to comprehending the complex origins of our universe. As explorers of the unknown, we stand on the precipice of revelation, poised to uncover more of the universe's secrets. In recent findings, scientists using a NASA space telescope made a fascinating discovery: a potentially Earth-sized exoplanet located astonishingly close to our solar system and possibly suitable for life as we know it. This extrasolar planet, named GJ1214b, orbits a small, cool red dwarf star situated about 40 light-years away in the constellation Pisces. Discovered by NASA's Transiting Exoplanet Survey Satellite, TESS, GJ1214b is estimated to be around 1.1 times the diameter of Earth, placing it in size resemblance with both Earth and Venus. Often referred to as an Earth-like twin, GJ1214b orbits its star, GJ1214, so closely that its year lasts only 12.8 Earth days. However, because GJ1214's red dwarf star is about a quarter the size of the Sun, it emits far less heat, positioning GJ1214b within its star's habitable zone, also known as the Goldilocks zone. This is the region where conditions are neither too hot nor too cold for liquid water to exist, an essential ingredient for life. While researchers are hopeful yet cautious about the planet's potential habitability, they note that its surface temperature of about 107 degrees Fahrenheit 42 degrees Celsius is cooler than Venus, which has a thick atmosphere trapping heat. In contrast, GJ1214b may have a relatively thin atmosphere, which could make it more conducive to supporting life. The exoplanet orbits a quiet red dwarf star, which increases its chances of retaining an atmosphere, despite frequent and intense flares from its star. This discovery offers a valuable opportunity to explore planetary conditions around red dwarfs, which constitute a significant portion of stars in the Milky Way and have much longer lifespans than the Sun, providing more time for potential life to develop. Future investigations using methods like the spiral speed technique and transmission spectroscopy with the James Webb Space Telescope are expected to reveal more about GJ1214b's atmosphere and potential biosignatures. This exoplanet, along with others in the TRAPPIST-1 system, marks a significant step in understanding the potential for life around red dwarfs. While it's too early to determine whether GJ1214b can support life, further research is eagerly awaited. Scientists remain optimistic, emphasizing the importance of continued study to unlock the mysteries of this intriguing world.